Hi, fifth grade. It is finally time to do the Oreo cookie activity where we will be modeling the plate boundaries. As you know, the 3 plate boundaries, which is the way that the plate tectonics move, is convergent, coming together, divergent, spreading apart, and transform, where the plates slide past each other. To understand this better, we are going to be using Oreos today, specifically double stuffed. And just to remind you, you do not need to go out and purchase these. You can follow along with my model. And if you have cookies like this at home, or I found some random crackers in my pantry, this would work too. So I'll show you what that looks like. To complete this lab activity, you will need to download the Oreo cookie lab packet. It's about 5 pages long. You don't need to print it unless you'd like to, and we'll walk through it together. Our first demonstration starts on page 1, where it says Oreo number 1, sliding plate over asthenosphere. The directions say that each person in the group completes 1 Oreo activity. Well, the good news is that you get to complete all of them since we're not in the classroom together. To begin, you're going to remove your Oreos from the packaging. And it looks like my husband had a few too many Oreos already. You're going to grab 1 Oreo. Before we begin the activity, I'm just going to give a quick explanation. This Oreo cookie, imagine it's like the Earth. The Earth is round, so it's kind of round, cylindrical. And imagine the entire chocolate cookie part is the crust, or the lithosphere, and the inner part is that ooey gooey asthenosphere. Everything else is not shown in this model. This is a simplistic model. So we have the lithosphere, which is the outer cookie. The cream is the asthenosphere. In order to show sliding plate over the asthenosphere, we're going to carefully, without breaking the cookie, remove the top cookie. Remember, this is the trickiest part. Oh, that worked out nicely. Then you're going to slide the top portion of the cookie over the filling. So remember, this is the lithosphere, or the plates, and we're gonna just slide them over the asthenosphere like this. And you can move it around, show the sliding in different directions. That's really it. This is to show you that the lithosphere, which is the crust and the top part of the mantle, floats over the asthenosphere. Once you're done sliding your plates over the asthenosphere, you are done with this portion of the lab. You don't need to do step 3, which says to place your cookie on the portion of your napkin marked sliding over the asthenosphere. We're just going to leave it as it is for this. Our second lab demonstration is looking at convergent boundaries. So we're going to follow the directions on page 2. It says, carefully break the top of the cookie in half. So what you're going to do is you're going to take this out. Do not break the bottom of the cookie. Then you're going to take this part and you're going to split it in half. If you're doing this at home, try to be gentle. Remember, it doesn't have to be perfect. If you notice mine, it's not perfect. All you're going to do now is step 2, bring the broken parts together in the center of the Oreo. So these are my 2 convergent boundaries, my 2 continental crusts. I'm going to show mountain building. Remember, the cream is the asthenosphere, the cookie, which I'm holding, is the lithosphere. All you're going to do is show convergent boundaries coming together and forming mountains like this. So I'm going to repeat this from this angle. You're going to take one part of the cookie off, keep the cream together, leave that as it is. You're going to take this top cookie, this is our lithosphere, split it in 2. Doesn't have to be perfect. These are our 2 continental crusts, and they're going through a convergent boundary. As they converge and come together, they form mountains. Remember, they're still over the asthenosphere, and the reason they're moving in the first place is because convection is happening in the asthenosphere. So here is our convergent boundary. We're now going to do a divergent plate boundary. This can be found on page 3 of your lab packet called Oreo number 3, Divergent Plate Boundaries. As always, we're going to start by taking one part of the cookie off, just like this, and follow the directions. Step 1, carefully break the top of your cookie in half. As a reminder, the top of the cookie is the lithosphere, like that. This time, we're going to pull the two parts of the cookies apart. So they'll be together like this, and we're just going to pull them apart. This is a divergent boundary. It's seafloor spreading. Divergent. And once again, we have the asthenosphere exposed. This comes up, cools down, becomes our new rock. Our older rock is on the outside. These are divergent boundaries. Our fourth and final demonstration is for transform plate boundaries. This is on page 4 of your packet. Just like before, you're going to start off by removing one part of the cookie like this. Then you're going to carefully break the top in half a final time. And remember, a transform boundary is when the plates slide past one another. This is happening over the asthenosphere. So we're going to show that friction, that transform boundary like this. If you notice, causes a lot of damage, it can even break. That's meant to happen to show that transform boundaries are often where earthquakes occur. On page 5 of your lab packet, you'll find this sheet over here. What I've done is I've summarized everything that you need to know about this lab. For the box sliding over the asthenosphere, here's the diagram and notes. Same thing for convergent boundary, divergent boundary, and transform boundary. I've also uploaded this onto Nightsite. Please review carefully and make sure that you're starting to understand these plate boundaries. If you want to draw these out as well, it would be really helpful to understand them even better. So if you don't have Oreos at home and you want to try something similar, it's not exactly the same, but you could definitely try to model this. I just have 2 random crackers I had lying in my pantry. You can find cookies, crackers, anything similar, just to show the plate movements. So convergent would be coming together, and you can try to hold it up like a mountain and balance it. Divergent, you would have them together and then start to spread apart. And finally, transform, where the plates slide past each other, you can cause damage. Now remember, these are only lithosphere. There is no asthenosphere here. That's why the model isn't fully as accurate, but I hope it helps you to understand the movements better.